Alright, this is more of an algebra problem than anything else. We're trying to find the percent abundance of these two isotopes, and we know the average is 24.31. So first off, we should know that this one is going to be the most common probably because the average is closest to that. So that gives us some idea about what the final answer should be. But in the meantime, we don't know. So we're going to call our percent abundance x because it's an unknown, so we're not sure what it is. I'm going to change this 10% to a decimal because it's usually easier to work with decimals than percentages. And we say, okay, well, if this is x and this is 0.1, what is this third one going to be? And if this isn't immediately obvious, we know that they all have to add up to 1, kind of like 100%. So if you needed to, we could temporarily call this y, and we know that x plus y plus 0.10 equals 1. And now rearrange this and solve for y. So y then equals 0.9 minus x. And so I'm going to replace this y with 0.9 minus x because I really would like to have it all in terms of one variable. So this is 0.9 minus x. And it's really important, too, to just test to make sure this makes sense. Okay, well, what if x is 0.3? If x is 0.3, then this should be 0.3 plus 0.1 is 0.4. This should be 0.6. Okay, good, it checks out. So always test that your equations, with algebra are reasonable. Just always do a quick test before you go any further. Okay, so now we just treat this as a regular average atomic mass problem. So what you do is you always take the masses and you just multiply them by those percentages. So 23.985042, it's really long unfortunately, times x, that's the percent, plus 24.985837 times 0.1 plus 25.982593 times 0.9 minus x, all of that has to equal 24.31. And now it's just an algebra problem that we just need to solve. I frankly am not interested in doing this whole algebra problem for you. You can play around with it, but when you're done, you should get x equals 0.7874 thereabouts. Which means that if you want to convert that back to a percentage, then this would be 78.74%. And this here would be, so that'd be 88.74. So subtract that from 100, and you would get about 11.26% here. But there's one last thing we could do just to check these answers are right, is now we could go back and use these percentages and these masses and just calculate this in a straightforward manner. So take this mass times 78.74% plus this mass times 10% plus this mass times 11.26%, and you should get this 24.31 back, which if you do that, you'll find that that is the case and it's true. So anyway, that's all this problem really is. It's largely an algebra problem more than anything else, and just making sure you set up that thing at the beginning, just that all your numbers make sense. Always test it, say like, if x is this, will this all work out? And that's it. So until next time, I am Derek Genova. Have a delightful day.